Power over Ethernet. General overview. Power over Ethernet refers to a standardized system which passes electric power along with data on a twisted pair Ethernet cabling. By means of a single cable, both data and electric power are provided to devices such as wireless access points, IP cameras, voice-over IP phones, etc. The development of the Power over Ethernet standard was carried out in 3 standardization phases: Power over Ethernet, Power over Ethernet Plus, 4 pairs Power over Ethernet. For applications, the main limiting factor affecting the use of Power over Ethernet was and still is the amount of available power. With each standardization step, the maximum available power for the end devices has been increased. Less than 13 Watt available at the powered device is in general sufficient for most IP phones and small wireless access points. IP video phones, more complex wireless access points, and IP cameras may require sometimes up to 25 Watt. Today, there is a demand for higher power to support devices such as very powerful PTZ cameras, smart lighting and building control devices. The following techniques for transmitting power over copper Ethernet cabling can be distinguished: Mode A, Mode B, Mode 4 pairs. Mode A transports power on the same wires as data for 10 and 100 megabit per second Ethernet variants with the phantom powering technique. Some implementations also allow the use of gigabit Ethernet with this mode. If this is the case, it should be noted that with gigabit Ethernet, data is exchanged over the 4 pairs. Transport Mode B separates the data and the power pairs. This is only possible for 10 and 100 megabit per second Ethernet variants. Some implementations also allow the use of gigabit Ethernet with this mode. In the latter case, there is, of course, no longer a separation between data and power. Transport Mode B allows also power injectors that are situated between a regular Ethernet switch and the powered device, thus injecting power without affecting the data streams. The power sourcing device, not the powered device, decides whether power mode A or B shall be used. This means that the powered device has always to implement both modes. The 4-pair transport mode provides power using 2 or all 4 pairs of an Ethernet twisted pair cable. It supports the use of 100 megabit per second, 1 gigabit per second and 10 gigabit per second Ethernet connections. IEEE Power over Ethernet standards have the capability to detect by the power source whether a device is conformant with Power over Ethernet. If appropriate, it allows the powered device and source to negotiate also the amount of power required or available. The original Power over Ethernet standard provides up to 12.95 Watt of DC power. The updated Power over Ethernet Plus standard provides up to 25.5 Watt of DC power. The Power over Ethernet standard for 4 pairs introduces 2 additional power types for the powered device, up to 51 Watt and up to 71 Watt. Here follows an overview of the power levels available. Within the generic cabling system, the Power over Ethernet concept is mostly applied in the horizontal cabling subsystem, when Ethernet on copper cables is used. A power sourcing equipment is a device that provides power on the Ethernet cable. This function may be integrated in a network switch, commonly called ENSPAN, or in an intermediary device between a non Power over Ethernet capable switch and a Power over Ethernet device called a midspan or a Power over Ethernet injector. Example of an endspan. An industrial gigabit Ethernet switch with 6 ports data and Power over Ethernet or Power over Ethernet Plus. Endspans are frequently used on new installations or when the switch has to be replaced for other reasons, such as moving from 10 or 100 megabit per second to 1 gigabit per second Ethernet, which makes it convenient to add the Power over Ethernet capability. Example of a midspan. Power over Ethernet patch panel with 12 Power over Ethernet and data ports at the floor distributor. Power over Ethernet injector with 1 Power over Ethernet port at the telecommunication outlet. This way of working may be interesting if only a limited number of outlet ports have to be provided with a Power over Ethernet function. Data cables in a structured network are not optimal for the transmission of electric power. Problems hardly occur in practice, as long as only a part of the cables are used for power transmission, and this only for Power over Ethernet or Power over Ethernet Plus. However, when 4 pairs Power over Ethernet, up to 100 watts, is used, heating of the cable may become an issue. An RG45 connector may include weaknesses in contact design, revealed when the link is connected or disconnected under power conditions. It is thus required that RG45 modules should guarantee a suitability of Power over Ethernet applications and a trouble-free operation of remotely powered end devices.